This is video B of Counting Principles, Permutations, and Combinations. We will be talking about combinations and how to distinguish further between permutations and combinations. We had seen earlier that a permutation is an ordered arrangement of a given group of items. A combination is a group of items taken without regard to their order. Permutation problems involve situations where order matters. However, combinations involve situations in which the order of items makes no difference. We can define a combination as the number of n things taken r at a time, and often you'll hear me say n choose r. This is defined as the number of possible permutations over r things at a time. And if we plug in our definition of what we know of n factorial over n minus r factorial all over r factorial, by simplifying this further, the definition of a combination is n factorial over n minus r factorial times r factorial. Notice that this definition is the same formula for the binomial coefficient of n over r. We can't use the fundamental counting principle to find combinations. We have to use this specific formula. So let's go ahead and look at example 8 and see how we can utilize our formula with combinations. A 3-person committee is needed to study ways of improving public transportation. How many committees could be formed from the 8 people on the Board of Supervisors? So we have a total of 8 people. We would like to choose 3 people, and we will go ahead and use the formula. Now, order doesn't matter here. We are using 3 people in general. We're not looking for the leader and a secretary or treasurer. This is all just pretty vague, and order does not matter. So we have 8, choose 3, and plugging in what we know, we have 8 factorial all over 8 minus 3 factorial times 3 factorial. So we have 8 over 5 factorial times 3 factorial. And plugging this in and canceling things out, you will be doing this a lot with these combinations. We have 5 factorial times 3 times 2 times 1. And the 5 factorials cancel out, giving our numerator of 8 times 7 times 6 over 3 times 2, and this is 56. So we have 56 ways that we can arrange 8 people into teams of 3. Now here is a good spot to introduce how you can use this on your calculator. I know everybody has a different calculator, an 83, an 84, 89, and we all have built-in modes in our graphing utility. So if we take a look at where we can find it, I know on an 83, if I hit Math and I go into a section of probability, you can see that I have my n choose r, I have my permutation function also. And the way that we use this is we go ahead and define our n before we go ahead and use that function. So I'm going to use the combination and hit enter. So I have 8 times n choose r, but I also need to define my r, which is 3 in this case. And if I go ahead and hit enter, my answer is 56. So I'll see if I can upload this TI-83 computer app. If you do not have a calculator at home, it has the same exact functions as a graphing utility. I would like for you to pause the video and answer got it question number 9. In poker, a person is dealt 5 cards from a standard 52 card deck. If the order did not matter, how many different 5-card poker hands are possible? Beyond that, I would like for you to fill in the blank with distinguishing between permutations and combinations by what you've learned so far. In which one of these will order matter? What about the rearrangement of the different items? And if you could fill in the equations for both of these. And this will conclude our 10.6 unit.